Today's lesson is on finding x and y intercepts when given a linear equation, and then using the intercepts to graph linear equations. So first I just want to talk about what it means to have an x-intercept or a y-intercept. I'm going to start by just plotting points on the x-axis, because a point that crosses the x-axis is an x-intercept. So I have 3 points, and I'm just going to label the points so we can get a visual of what these points look like. Negative 1, 2, 3, 4. This is negative 4, 0. The second point is negative 1, 0. And this last point is 2, 0. So what do you notice about those 3 points? What do they all have in common? What you should notice is that on the x-intercept, all points on the x-axis, they all have the same value for y, and that is 0. So every x-intercept, y is always 0. So this information we will use to do the problems in this lesson. But now I want to think about the y-intercept. So if I just plot 4 points, or 3 points, and then label them, this is the point 0, 4, 0, 1, and 0, negative 2. So what do all of these points have in common? The y-intercept, it means that x is always 0. So if we ever want to solve for the y-intercept, we just have to know, to find the y-intercept, we have to look at what happens when x is 0. So here we have the linear equation 7x plus 3y equals 21, and we're used to graphing lines from equations in the form y equals mx plus b, and when they weren't in that form we would have to solve them for that form. Well, here's another way that you can graph. You can graph these equations without having to solve them in y equals mx plus b form, and that's by finding the x and the y intercepts. So let's go through this process. What do you remember about the x-intercepts? What you should remember is that the point is always x and then y equals 0. So to find the x-intercept, I'm going to plug 0 in for y and solve for x. So 7x plus 3 times 0 in for y equals 21. And now I can solve this one variable equation for x. So 3 times 0 cancels out, and it leaves you with just 7x equals 21. And then how do you solve for x? You have to divide both sides by 7. So you should get that x equals 3. And what that means is that the x-intercept is the point 3, 0. So on the x-axis we can plot the point 3, 0. Now we're going to do the same idea to try to find the y-intercept. So the y-intercept is always the point where x is 0, and then you have a value for y. So to solve that, we're going to plug in 0 for x and solve for y. So if you rewrite the equation, 7 times 0 plus 3y equals 21. And now we're going to solve for y. Well, 7 times 0, that cancels out. And we're left with 3y equals 21. So divide by 3 and divide by 3. You should get that y equals 7. And if y equals 7, then that means that the y-intercept is at the point 0, 7, because that's what y equals when x is 0. So if we plot that point, 0, 7, we have the other intercept. So now we have 2 points. So if you just have a straight edge, you can connect those 2 points, and it's going to create a straight line, which is the graph of this linear function. So instead of finding the slope, you can find the x-intercept and the y-intercept, plot your points, and connect to make your graph. Alright, let's do the same thing with this equation. Negative 3x plus 5y equals 15. The x-intercept is always the point x where y is 0, and the y-intercept is always the point where x is 0, and then we know the value for y. So to find the x-intercept is always when y is 0, so I'm going to plug in 0. I'm going to plug 0 in for y. So negative 3x plus 5 times 0 equals 15. And now I can solve for x. 5 times 0 will cancel out, and I'm left with negative 3x equals 15. And now I can just divide both sides by negative 3. So x equals negative 5, which means the x-intercept is at the point negative 5, 0. So I can plot that point at negative 5, 0. Now I'm going to do the same thing, except I'm going to find the y-intercept. So I'm going to plug in 0 for x and solve for y. So negative 3 times 0 plus 5y equals 15. So the negative 3 times 0 cancels out, and I'm left with 5y equals 15. Divide both sides by 5. So y equals 3, which means the y-intercept is at the point 0, 3. So if I plot that point 0, 3, and then you can get your straight edge out, and you can connect these two dots and extend the line so that you can graph the full line of the linear equation negative 3x plus 5y equals 15. Okay, same type of thing. I want you to write this down and then pause the video and try it on your own, and then come back and check if you found the correct x-intercept and y-intercept. If you plug 0 in for y, you should get that x equals 1.5, which means the x-intercept is at 1.50. And then when you plug 0 in for x, you should get that y equals 3, which is the point 0, 3. So if you plot that point 0, 3, and then you can connect the two intercepts and extend the line to graph your full equation, 2x plus y equals 3. Alright, here is our last example. It says, the student council is sponsoring a carnival to raise money. Tickets cost $5 for adults and $3 for students. The student council wants to raise $450. This scenario can be represented by the function 5x plus 3y equals 450. And we want to graph that equation. And we're going to do that by finding x and y intercepts. So we can find the x-intercept first, and we can do that by plugging in 0 for y. So 5x plus 3 times 0 equals 450. So the 3 times 0 is 0, so that cancels out, and you're left with 5x equals 450. And now divide both sides by 5. So x equals 90. And if you go back up to the situation, we have 5x, and we just solved x equals 90, and that corresponds to adults. So to raise $450, we would need 90 adults. Now, let's do the same thing but solve for the other intercept. Alright, so let's plug in 0 for x this time. So 5 times 0 plus 3y equals 450. 5 times 0 cancels out, and you're left with 3y equals 450. Divide both sides by 3, so y equals 150. So you have the x and the y intercept. So now we have to graph those two intercepts. So to graph this equation, we need to graph the two intercepts. We need to plot 90 on the x-axis and 150 on the y-axis. But that means we have to label our graph, and we can count each unit as 10. So 10, 20, 30, 40, 50, and then 60, 70, 80, 90, 100, and then 110, 120, 130, 140, and 150. So 150 is the y-intercept, and now you can count by tens on the x-axis as well. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and we actually want to plot the point at 90. And then to graph, we just have to connect our two intercepts. And there we have graphed the equation. So still graphing linear functions like we've been doing, but learning a new way, and that's by finding the x and y intercepts by plugging in our zeros. Good luck with the lesson.